All right. I would like to invite everybody to our first webinar Wednesday. Just in case you're just joining now, I'm going to intro Rex Alexander. But first, I'm going to tell you about laser vision. And Rick, we're good to go? All right. So I want to thank you for joining. We are Laser Vision, and I'm the Director of Sales, Andy Barrows. And just so everybody knows, Laser Vision is a global laser safety company. We focus on laser safety PPE, training, curtains, anything in regards to laser safety. So what we're going to do is we're going to do webinars so that we can interview people and help teach the industries about lasers. And they're using lasers in many different industries now. So that's kind of the fun part. Today we're going to talk with Rex Alexander about laser welding and talk about his experience. So with that, I would like to introduce Mr. Rex Alexander. Mr. Rex Alexander, congratulations and thank you. You've done such a ton of work recently, so congratulations on everything that you have going on. I would like to start by just asking you your background. How did you get started in this? Where did all this come from? Tell me a little bit about yourself and why you are an expert in laser welding.
Yeah, sure. So I'm an Ohio State welding engineer. I have a bachelor's and a master's in welding engineering. I've been doing laser welding for the past 10 years or so. So mostly in the aerospace industry. I've done laser cladding. I've done deep penetration keyhole welding, 3D printing, part marking, cutting, cleaning, you name it. If it shoots a laser at a rocket or part of a rocket, I've pretty much done it. I got involved with the world of handheld laser welding back in 2021, early 2021. I started at SpaceX back in 2020 to build the laser welding program for Starship. So in the beginning, it was all automated laser welding, automated laser cutting. And then eventually Elon saw some TikTok video of some guy in China doing handheld laser welding. And he sent me a laser that he bought on Amazon. And I was like, dude, this is terrifying. I want nothing to do with this. This is putting a class 4 laser in someone's hand is the last thing I want to do. The laser should be in a box. And so I kind of swept it under the rug for a while. And then IPG came out with their light weld system in late 2020. So I picked one of those up in early 2021, started playing with it. Still wasn't sure about it. It seemed super dangerous. We didn't know what to do with it. And I'll be honest with you, IPG didn't know what to do with it. They were just making it. And this was a side project for me at SpaceX. I just thought it was kind of a neat technology, something interesting to play with. And eventually it became a very mainstream process to build Starship. Lots of advantages. It's lower heat input. It's faster. It's easier to train people. And by the time I left SpaceX, we had a laser welding program, a handheld laser welding program with over 100 lasers, hundreds of trained operators, and upwards of almost 9 kilometers of handheld laser weld on Starship. And when we're talking about this, we're talking about high performance structural joints qualified to aerospace code. So I think that's probably one of the most advanced handheld laser welding programs in the world. And I got tired of looking at the rest of the welding industry who I think, I don't blame anybody. You see all the Chinese TikToks on the internet and it looks fake even to me, and there's no good information out there. And so I left SpaceX about 2 years ago and founded the Handheld Laser Institute. And my goal is really to help generate the data and teach people and share the knowledge that we have so that we can make handheld laser welding a normal thing in the industry, much the same as we saw happen at SpaceX.
Oh, fantastic. So the Handheld Laser Institute started about a year or two ago, I think, right?
It started about 2 years ago. Yep.
Great. So tell me, just kind of in real common, everyday terms, what do you guys teach? What is the Handheld Laser Institute doing? What are you doing for people in a day-to-day interactions?
Yeah, so we touch every aspect of handheld laser welding. We've got a comment that says they're seeing blank screen and no audio.
All right. Well, that's anybody else comment?
Zach can see in here.
Zach
So
commented he can see.
it may
All
just
right.
be one. Okay. All right.
We're good.
We've got lots of people.
Thanks, Matthew.
Okay. Thanks everybody for commenting. We're good. Okay. So yeah, what do we do on a regular basis? We pretty much do anything and everything that has to do with handheld laser welding. So this started out with me just doing consulting for people. And I'll be honest with you, this was supposed to just be part-time consulting for me after leaving SpaceX, and it's been anything but. So I have 3 employees now. We run a metallurgical lab. We have a bunch of lasers that we evaluate. So we'll do anything from helping people understand what sort of equipment they need and speccing out the equipment for their applications. We'll do applications development. We'll do weld qualification. qualification, do training for operators and training for engineers. We do those trainings out of our facility outside of Seattle, Washington. We travel to do them as well for folks. So we do private training at people's facilities. And we've started recently as well doing training in conjunction with community colleges all across North America.
Okay. And then you're training corporate offices, end users, a mixture of everything. Like if we're talking, I mean, because right now in our group here, we have large corporations and we have people in their garage just interested in handheld laser welding, right? So who is your main target that you're helping out nowadays?
Yeah, I'd say we help almost everybody from one-man shops to Fortune 500 companies, people building lawnmower parts all the way up to rockets and airplanes. So we touch just about all of it. And there's different equipment that makes the right sense for people at different price points and different types of organizations. And so it's sometimes difficult to sift through all those options. So we help people determine the right equipment for their applications as well.
Excellent. So let's kind of dig into laser welding. So that's the background, right? SpaceX, Institute, training. Rex has a ton of background in this industry that is just really starting to explode. So I'd like to talk to people that, don't know a lot about laser welding. They know they've heard of it, maybe they've tried it, maybe they've seen some TikTok or some YouTube, and like you said, some of the stuff is kind of out there and not sure what's real and what's not real. So let's just kind of talk about laser welding to start off with. So in regards to laser welding, before you even get one, you're interested, you're a corporate office, you're a garage mechanic, whatever it might be. Before you get one, let's just talk about some of the things that they should be aware of. So, what are some safety things? Because I think that's one of the biggest things in the industry. What are some safety things people should be aware of before even buying it, or if they bought one, immediately after receiving it?
Yeah, I mean, I think number one is you have to remember that you're working with a class 4 lasers. So for people who might be less familiar with laser safety and laser classifications, the use of high power lasers in North America is governed by ANSI Z136.1, and OSHA requirements typically just point directly to ANSI Z136.1. So there's 4 different classifications of lasers. Most lasers, if you're looking at like a big flat pattern cutting laser, is what we would call a class 1 laser, where the operator does not need any specific PPE to keep them safe. The laser light is contained entirely inside of the machine. A class 2 laser, I like to think about this as your barcode scanner at the grocery store. So those are perfectly safe. Your blink reflex will protect you. There's no hazard in having hundreds of these at the checkout when you go buy your groceries. Your class 3 lasers, these are your high power laser pointers, anywhere from 5 to 500 milliwatts. And then the class 4 laser is really where the hazard becomes much more extreme, and you could experience instantaneous and permanent blindness with effectively no prior warning, because these laser beams that we're using are infrared, they're invisible. And these class 4 lasers start at 500 milliwatts, or about half a watt. And most of these systems that are on the market, they're anywhere from 1,000 to upwards of 6,000 watts for some of these handheld laser welding systems now. So it's many orders of magnitude higher than where a class 4 laser starts. And what this means is you can have eye damage not only from a direct hit, but you could have eye damage from a reflected beam. So understanding laser safety, both from a PPE standpoint and from a best practices standpoint, is extremely important for anybody who's looking at bringing one of these into their shop, wherever they are.
Perfect. And again, the way I always kind of put class 4 means that if you get a strike with a laser, it's instant, right? You don't have time to turn your head. You don't have, it's instantaneous. So that's why it's so important. And the PPE you use has to be, for the correct device. So you can't just go use any PPE. You can't use standard welding PPE. You can't, don't order things online if you're not 100% sure what you're getting. Do not just order something online, because it's just too big of a risk. Like you said, these
Yeah,
lasers are powerful.
and I'll even say on that front, I've trained people with all kinds of different equipment. Sometimes people buy equipment, we show up and we start training them. And I trained someone last summer, and they had ordered a piece of equipment from China. It had been delivered with laser safety glasses, and the laser safety glasses were stamped with an optical density of 5 at 1,070 nanometers, which is not adequate. And that is assuming, of course, whoever manufactured them in China actually did any sort of testing. So I usually warn people, don't necessarily buy your laser PPE from Amazon. Yes, it might be cheap, but you've only got two eyes and they're best without holes in them. I think it's important just for a second to touch on what actually happens to your eye when a class 4 laser beam hits your eye, even if it's a reflection. Effectively, what happens is your cornea will refocus that beam onto your retina and vaporize, if you're lucky, vaporize just a portion of your retina, and you'll end up with what we call a floater or a black spot in your vision. If you're unlucky, then it's lights out for that eye and you won't be seeing anything anymore. And it's irreversible and instantaneous. So having the proper PPE is essential. And I know we're kind of preaching doom and gloom here. And yes, you can go blind, but if we take a step back for a second, between SpaceX and the Handheld Laser Institute and my other trainers I have working for us, we've trained well over 1,000 people over the past 5 years. I've yet to meet anybody who's actually had an eye injury from a handheld laser. I think there's a lot of caution, a lot of hesitance around handheld laser welding as a whole, because yes, it is a dangerous process and you are putting a class 4 laser in your hand, but I think you really have to put it in perspective with respect to everything else that's in your shop. There's all kinds of other dangerous equipment in most fabrication shops, whether it's an angle grinder, a forklift, a bottle of compressed gas, or a lathe. All of these can do some pretty terrible and irreversible damage, but we know the proper approach to handle these things, and we know the proper PPE to wear around them. Using a handheld laser is no more hazardous than anything else you're using. It's just a different type of hazard. And once you become familiar with that type of hazard, the best practices and the PPE, it's no more dangerous than anything else around you.
Yeah, no, totally agreed. And I think the biggest thing is just education, right? It's just educating yourself with the proper people that can tell you what to do. A lot of times the laser manufacturers can guide you. So those are great first resources. Rex, of course, is great at training, but I don't think you want a bunch of calls like, hey, is this the green one or is that the green one? That's what our company is for. We're going to help you with all that. Green, gray, helmets, face shields. We'll get into that in just a minute. In regards to, as you mentioned, reflection. And as we talk about lasers, if I take a laser pointer, I can point it to the moon, right? But that's not a class 4 laser. So whether it goes to the moon or it goes 2 inches, it's okay. When we're talking about a class 4 laser and the distance it could travel, what do we call that? And what have you seen for ranges? Because again, the goal here is that people understand the dangers before they get it so that they can take the proper precautions. If you've got a big garage and you've got 10 workers and one person with a laser, what does it mean to the other 9? So I just want to talk about that for just a minute, if you don't mind.
Yeah, absolutely. So what you're referring to is what we call the nominal hazard zone or the nominal ocular hazard zone, because we're also worried about skin injury as well. So typically, from an ocular standpoint, your nominal hazard zone, let's say with a single mode 2 kilowatt laser with standard optics, most of these systems on the market have a 50 millimeter collimator, 120 to 150 millimeter focusing lens. You're typically looking at a nominal ocular hazard zone of somewhere on the order of about 650 feet. And that's full power looking down the barrel of the gun. That is what I would call a worst case scenario. And there's a number of engineering controls associated with most of the higher end machines that help avoid this, what we call intra-beam hazard, looking directly down the optics. But it is extremely important to know that, yes, theoretically, down the barrel of the gun, you could harm someone's eyesight from 650 feet away.
And that's kind of the starting point that ANSI or OSHA or any safety officer would want to do is think about the worst case, right? So if you're standing in the middle of your warehouse and you throw a football, if I could, 656 feet in the direction, that is the zone that you have to be aware of. And if, again, and not just this way, but also this way, right? Some of these buildings have catwalks, they have offices,
Yeah.
everything in line of sight. So that's what people have to be aware of. And that's what we can help with. So I hope that answers some of those questions as well. And then
Yeah.
reflections too. So if you could, I know that when you're welding, some material has a higher chance of reflection than other ones. So could you give just a quick background on some of the things you've seen in actually getting beams bouncing off material and actually hitting things?
Yeah, so there's really with class 4 lasers, there's 3 types of hazards. So we talked already about the intrabeam hazard or looking directly down the barrel of the gun or through the optics. That's really your worst case scenario. We also have 2 other types of hazards associated with reflections. And one is what we call a specular reflection, where the beam is still focused as it bounces off of a reflective surface. And the other one we're worried about is what we call a diffuse reflection, where the beam goes in all directions after bouncing off of that surface. And as you mentioned, the likelihood of having a specular or diffuse reflection really depends on the type of material that you're welding and how reflective it is. What's really interesting is when we're welding, the reflectivity is not necessarily so much a function of your surface finish, but it's more a function of the material properties of the metal that you're welding specifically. So materials like carbon steel, stainless steel, nickel-based alloys are typically what I would call highly absorptive to infrared wavelength, which means they're absorbing a lot of that laser wavelength. So with these materials, you're more commonly worried about a diffuse reflection. And your nominal hazard zone, you can talk to third-party laser safety companies, Laser Vision as an example, who can help you do these calculations. For a diffuse reflection, even with full power and the worst viewing angle possible, your nominal hazard zone with a diffuse reflection with most of these lasers ends up being only about 10 feet, which is the reason why we can build these enclosures without roofs. That is, unless, like you mentioned, anybody has a mezzanine or a catwalk or elevated work going on above the laser safety enclosure. What I think is probably more dangerous is what we call a specular reflection, where that beam is bouncing off of reflective material, for example, aluminum or copper. Now, aluminum and copper have their own challenges with laser welding from a process, like a fundamental physical process standpoint. But the specular reflection can absolutely be a hazard with these two materials. I think aluminum is more common in the industry, where, let's say in a worst case scenario, maybe you don't have the right parameters put into your machine, maybe your focus position is set incorrectly, or your optics are dirty, and you can actually get a specular reflection coming off of the part that could, in some instances, ignite surrounding materials, burn your glove, or even potentially come back in and melt some of your welding hood, depending on your position relative to the torch.
I got to tell you, it's not common practice, but it's also not impossible. We have seen it, and especially when in an industry where people are learning, right? So, I mean, this isn't something where somebody's got 10 or 20 years experience. Nobody essentially has 10 or 20 years experience for the most part. Everybody's learning. So safety is such an important aspect. You really have to make sure that you have the proper thing and that you're wearing it properly and at the right times. So when we're talking about the right times, we're talking about any time that a laser is on and it's in operation, right? So I think that that's kind of the key too, is that people recognize when a laser's on, you have a area that you want to keep protected, and that's what we call the optical hazard zone, and that's how we use curtains and enclosures. Now let's just talk about the material for a second, since we kind of went down there. The material that's being used to absorb these potentially reflective or direct beam exposure can't be standard curtain material. Now, of course, with welding, they already have curtains all over the place. They're very common. Those curtains aren't made for laser absorption. So what experience do you have with curtains and putting those up? I'm sure that you've seen some custom jobs with large curtains. I'm sure some of the past experience, you've seen some very large projects. But curtains and rigid enclosures, a quick background with what people can expect.
Yeah, I'll tell you, I've pretty much done it all. You can get as creative as you want to be. I think the important thing here is, if we back up for just a second, we need to talk about the laser safety officer, and then let's get into these enclosures and the materials and kind of what you can do. Anybody who is planning on using a handheld laser, or any type of class 4 laser for that matter, is required by ANSI Z136.1 to have a certified laser safety officer designated as part of their staff. And there's all kinds of places to take these courses and become a certified laser safety officer. This is where this individual will learn specifically about the hazards associated with class 4 lasers, how to analyze them, and how to properly set up the correct PPE and designate a laser controlled area. So once you have a certified laser safety officer on your team, they can help designate what makes sense or what doesn't make sense for laser safety material. Now, to your point, absolutely, welding curtains are inadequate for blocking infrared light that we're using with the laser. Most welding curtains are designed to block ultraviolet light, which is a different wavelength. So curtains are, a great, I would say, early stage solution for people who are looking to implement handheld laser welding, especially if they already have welding booths with curtains already set up. I helped a customer last fall who had, somewhere on the order of 15 plus welding booths with curtains in their welding area, and they wanted to set up a handheld laser. And so we helped them get some curtains from Laser Vision, and we simply hung them on the same rails they already had. And pretty easily, in a matter of an hour or two, they had an area that was now a laser safe enclosure that they could do all their laser welding in. So curtains, I think, are the easiest and one of the least expensive places to start. Depending on what you have set up, there are also hard wall options. And one of the things that I really like about the hard wall options is that they're typically modular. So, we had a customer, they're built on 4-foot panels. So I had a customer almost a year ago who bought a 12-foot enclosure from Laser Vision, and then they called me and said, hey, look, we have a wall in part of our facility, and we'd love to make this enclosure bigger. Can we just use part of like the wall of our building as the back? And I said, yeah, sure, that's not a problem. And so instead of having a 12 by 12 enclosure, then all of a sudden, they I don't know the exact dimensions they had at the end of the day, but it was almost twice the size because they're using the wall of the facility. So having that laser safety officer that'll enable you to evaluate the hazards and help come up with the right solution is super important. Now, like you said, there are the curtain solutions, there are hard wall solutions, and sometimes, those work really great, I would say, for small to medium-sized parts. But as you mentioned, yeah, sometimes you work on really big parts, maybe parts that are effectively a room, and you can get pretty creative about what you do from a laser safety standpoint, as long as your laser safety officer understands the requirements. And the baseline requirement for a laser safety enclosure is that you're protecting what I call innocent bystanders from the light, right? People who may not be aware of the hazard, but you don't want to accidentally blind them as they're walking by or trying to peek in and see what's going on. So the real goal with these laser safety enclosures is to prevent any viewer who might be outside of the area from actually seeing the weld going on, unless it's through laser safe glass. So a lot of these solutions as well have a laser safe glass that's inserted into the enclosure, so bystanders can see what's going on without necessarily entering the room.
Yeah. So, and again, the curtains have ratings on them that say laser proof. They actually tell you what the ratings are. We can help anybody. If you have a 6,000 watt laser or a 1,000 watt laser, you're going to have different types of curtains. So we can help you with all that. And again, you're going to want to make sure that the signs on there. We like to have windows just so you can see what's going on inside. They have to lock. We can help with all that. And like you said, we can get creative. If you have curtains already set up, we can put those. We can design around a wall and make an L shape. So let's talk about LSO real quick, because I want to make sure that people, again, are aware of what is an LSO. How do I become an LSO? Do I have to be a certified LSO? You use the word certified. So it's a big question out there where people just don't know, like, number one, if I'm an LSO in Florida, am I different than an LSO in Texas? How do I become an LSO? Do I have to become? So can you just define first, what does LSO stand for? And then how do we get people to understand, how do I become a registered, or I am a, let's just say, I don't want to use the word certified because we can talk about that. But it's a gray area that people just seem to have a hard time understanding.
Sure. Yeah. So I'll answer a few of them, and I'm going to turn it back to you because you guys are the laser safety experts. So your LSO is a laser safety officer, and they're the individual who is in charge of all class 4 laser operations and determining the correct PPE, enclosures, creating standard operating procedures, et cetera, for the facility. And in terms of becoming one, you guys have plenty of training. I'll say here at the Handheld Laser Institute, we give people crash courses in practical laser safety as part of our training. But typically we default to folks like you to give people a laser safety officer certificate or do that training, because I think it's a great option.
Yeah. And a couple of options there. We have an online LSO course for laser welding, which gives you a broad outline of what an LSO. It's congratulations, you bought a laser. Here's what you need to know. To become a certified LSO is it's a different project. I mean, that's many hours. It's a lot of studying and tests. So it's a little bit different. We're here to help navigate those waters. So when people want to know what an LSO, how do I become an LSO? We have different ways and different levels of becoming an LSO. And again, you don't have to be a certified LSO. An LSO just means you're taking that responsibility. I acknowledge that I need to know these things. And we have a certificate of completion course online. Works great. We can help answer those questions. So I think I saw some of the people asking about LSO here, and I think that's a great way to kind of talk about for people to be prepared for that. So in regards to regulations, we talked about different states. We talked about LSO. Is there anything else in regards to regulations that we haven't come across? I know we talked about ANSI and OSHA, but in regards to different states and things, what have you come across?
Yeah, so there are different states that have different requirements. And typically this can be covered as part of LSO training as well. But I would encourage anybody who's looking at specific requirements. Again, OSHA defaults to ANSI Z136.1. That's the governing code body that rules the use of Class 4 lasers in North America. It's important to note, as you mentioned, though, Andy, there are a handful of states, not many, I think it's less than 10, that have specific state laws surrounding the use of Class 4 lasers. And I'll tell you, one of the things that was surprising to me in Texas, you think Texas as usually being the land of the free and very little restrictions. Interestingly enough, Texas is one of those less than 10 states that does have additional safety measures that are required. And one of the requirements to Texas state code is that you have to register each Class 4 laser with the state and keep track of where they are, much the same as you would treat any sort of, let's say, X-ray generation equipment. And that to me is pretty interesting. I live in the state of Washington. We're just outside of Seattle. And so the state of Washington requires, as an additional part of their Class 4 laser requirements to Washington state law, that employers must give employees laser safety glasses free of charge. So there are a few states that do have some additional requirements. So I would encourage you to investigate. Mr. Google is your friend, right? Google can help you. Obviously, Laser Vision, you guys have some consultants that help people as well. But definitely double check to make sure that you're following all state requirements as well. And in the vast majority of cases, 80% of the time, you have no additional state requirements. But again, there are a handful of states that do have additional requirements.
Florida's the same way. You got to register your laser in the state of Florida. And, again, it's one of those things where a quick search can help you. We can help you. So that's kind of one of those things that we just kind of want, make sure people are being aware of. So let's just talk about the PPE real quickly, because I know we get a lot of questions about getting the eyewear and what is the, helmets and face shields and this and that and some applications. So I have some behind me and I've got some here. So I know that this is a face shield that you use a lot. This is our face shield intended for laser welding. We have different shades. So can you give kind of your perspective on using a shield, which is a face shield, versus a helmet like behind me? What have you seen being an advantage for you? And maybe it depends on your atmosphere. What do you think?
Yeah, and let me give kind of a historical perspective here too, because I think we touched on this earlier. People have been arc welding for a long time. People have been arc welding for over 125 years, and I'll tell you, we're still learning about arc welding and making it better. If we're being generous, handheld laser welding's been around in North America for 5 years. The first system came out in China in 2017. So as a whole, it's a very, very new technology and things are constantly evolving. So when I first started doing handheld laser welding back in 2021, obviously at all times I have my laser safety glasses on. I like to tell people that's rule number one, right? Rule number one is wear your laser safety glasses. That's what's keeping you safe from the laser light. But back then there were no hoods or no laser safe hoods. And so I would typically just use a standard auto darkening welding hood, and I would put it on grind mode because the laser weld is not very bright. But I was always really nervous about using the laser, and I would always either squint my eyes up so I could feel the glasses on my cheeks, or I would put my hands up under my hood and touch my glasses and confirm that I had them on, because I don't want to go blind. I got 2 kids I want to see and a wife when I go home. I had, I would say, a very early prototype of a laser safety hood that was built using carbon fiber and multiple lenses. And undoubtedly, it's extremely safe, but it's also extremely expensive. And I think overkill for a lot of applications. So I used that hood for a couple of years. And it was fine. It was great. I'll tell you, I never bought a lot of them in my previous life because I'm sorry, I had upwards of 100 laser welders, and those hoods cost $1,300 a piece. I wasn't about to go spend, $100,000 on these carbon fiber welding hoods. We ended up making some of our own before official ones came out. You guys, I think, have been working with some folks to make also some passive welding hoods. So it's basically just it's like a plastic standard welding face shield with like a 3x5 piece of laser safety glasses put in there. So I built some of those at SpaceX early on to give to people as a secondary safety measure. But it was about 18 months ago at FabTech, I was at your guys' booth and I saw that face shield. And the face shield is something that I had been looking for ages. And I think I originally told you guys, I was like, look, at the time I had a 4-year-old, he loves to know what's going on in the shop, and I didn't trust him to wear laser safety glasses. And so I told you guys, look, let me have one of these face shields because I want to give it. I already had kid size laser safety glasses for him, but I don't trust him to keep those on. And so I said, let me get one of these hoods. I'll put it on. This will make me feel a lot better. And funny enough, those hoods are really lightweight. They're extremely comfortable. They have excellent visibility. And they're on the order of like $350. And so from a
Only
cost
three and
standpoint
three
as
fifty.
well, they're very, very attractive. And so we've been using those for the past 18 months or so exclusively, both for ourselves, for our students, and for a lot of our customers, combining those face shields with laser safety glasses. As you mentioned, there are also some, yes, very cool. You have a neat pattern on those ones.
Just
Yep.
like
So
that. And again, what we want to encourage people is to wear both of them. You probably can't hear me very well at the same time. So when you lift your hood to check your weld, you're still protected here, right?
mhm.
So we're going to encourage people to use a face shield and laser eyewear, or a helmet and laser eyewear, so that when
Yeah.
you pop up to take a look, you're still protected.
And there's a lot of reasons to wear both, actually. And I'll tell you, anybody who's, I would say, a casual observer in the laser safety area, they're fine wearing just the glasses. But for anyone who's welding, I think there's two reasons that you want to wear both. Number one is there is still some UV light from the laser weld. There's still a plume of vaporized metal above the weld that has some amount of visible light and UV light. And you could get some arc flash from laser welding. So wearing a hood, whether it's the passive face shield or whether it's the auto darkening hood that you have behind you, I think is really important to protect your eyes from the UV and the visible light as well from the welding. But then, as you mentioned, you're inevitably going to be in a situation where you are not the only person in a laser welding cell who is using a laser. I think most people start out with one laser and one laser cell, and then very quickly, especially if it's small parts, I've seen a lot of people graduate to using two lasers or multiple lasers. We had some things set up in the past where we had 6 lasers inside of one laser's controlled area. And inevitably, you're going to want to pick up that hood so you can see your weld better and kind of do a quick quality check. And if you're only wearing a hood, someone else might be welding beside you or behind you, and you run the risk of catching a reflected beam. And so you really want to have those glasses on at all times. And I'm going to emphasize this. Rule number 1 of handheld laser welding is wear your laser safety glasses. There is no excuse. There is no reason to take them off. If you're inside that laser controlled area, you must have them on. They're the only thing keeping your eyes intact.
I want to highlight, I think a lot of people think, well, how can I walk around? How am I going to walk around and do with dark green laser glasses? But I want to let people know that this is a laser eyewear that's got a very high visibility. You can see, you can walk around this and see perfectly fine. You don't have to wear it dark. And this has actually a high enough OD, OD7, OD8, OD higher than OD8 at the 1060, 1070, 1080 wavelength, which is where laser welding originates. So I want people to know that there are options out there, both helmets and face shields and even gray color. I'm going to encourage, make sure you're buying from a source that's very reputable. You can't find these types of products at a local hardware store. You can't find them from eBay. Don't go to Amazon. Trust from a source that you can rely on. So,
Yeah.
listen,
I,
Rex,
I want to
this
touch
was
on the
fantastic. Yeah,
Yeah, I want to touch on the color just really quick because I think it's super
please. Oh,
important
yeah.
before we move on. The color is really, really important. I think a lot of systems, especially the Chinese systems, typically ship with green glasses because they're closer to, say, like a shade 3, shade 4 welding lens. The problem that I have with the green glasses is that, yes, they are also darker, as you mentioned, so it makes it kind of a hassle to wear as normal safety glasses. But then often the green color, especially if it's a darker green with a lower visible light transmission, often cuts out the red pilot laser. And being able to see the red pilot laser as an operator of one of these machines is really important for getting high quality welds. And so the gray glasses that you held up, I think you guys have a pink filter as well that works pretty nicely, has a high visible light transmission, and then also allows that red light to come through is super important. And so combining a high visible light transmission laser safety glass like you had there, those gray ones, with a face shield, that gives you everything you need for both using the laser safety glasses as standard safety eyewear and laser safety eyewear without it being a hassle throughout the day.
Perfectly said. Thank you. And again, the whole I get it, so everybody knows the idea here is we want people to understand what it's like to actually have these devices in their hands. A lot of people have never used these before. They know it's coming. They want to get used to it. Rex's organization is just a fantastic tool. I mean, I know you're busy. because the only time you have is usually behind your windshield. So thank you very much for taking this opportunity. I hope a lot of people had a chance to learn something here and now have learned more about your institute. And I know that you're going to do great things coming up. So maybe 5-10 minutes. Rick, do we have any questions? That seems something that we could ask Rex before we let him go here. Let's see if I have anything specific.
So it looks like we've got one here. Standard flame retardant curtain can't necessarily be used as a laser curtain for a laser welding system. And I would say correct. If you have your standard curtains that you've got for welding, it is not necessarily something that you could use with a laser safety enclosure. There are specific standards. And I'd encourage you to work with Laser Vision, for example, and help understand those requirements. I think it's typically, correct me if I'm wrong, Andy, but it's a minimum power per unit area for what is 100 seconds for something to be rated for laser safety.
Yeah, so every curtain, every enclosure, everything that you buy from our company, everything is going to have ratings on it. Now, again, these ratings can be confusing at first, so we'll help guide you through it. But what our team does is we ask you the questions, which is which laser are you using, what's your power, what's your wavelength, and then we can help determine which curtain material is best for you. And sometimes it's a thinner, sometimes it's a thicker. All depends on what type of equipment that you're using. And again, you want to make sure that you don't just have standard curtains up, because if you ever have an inspection, if you ever had a reason for a liability, if you don't have the proper curtains up, then of course you just want to take those precautions. So, and we have a very affordable ways to do such. That's a great question, though.
So Matthew has a question about common materials that are used in laser welding and what hazardous effects those could have. His example was a PVC with chlorine gas coming from it.
Yeah, so I can comment on the metals side of things. We don't do a whole lot with plastics here. Now, from a metal standpoint, we are vaporizing the material that we're welding. That's part of how we generate the keyhole and get our deep penetration into the part. We've done some early level studies on stainless steel, and I know people who are typically welding stainless steel are worried about hexavalent chrome. Interestingly enough, when you're handheld laser welding stainless steels, at least austenitic stainless steels, most of your fume generation is actually manganese, which is present as an alloying element in your filler materials. And the reason that it's most prevalent in the fume is that it has a much lower vaporization temperature than any of the other alloying elements. So fume extraction is extremely important. I know we've talked a lot about PPE and eyewear, but having adequate ventilation and fume extraction is super important. Whether you have a fume extractor or, one of the things I'm really excited about is we've had a few customers now that have purchased PAPRs or positive air pressure respirators. Laser Vision has a couple options of those right now, which work really great if you're in a confined space or don't necessarily have great or adequate ventilation in the welding area.
But I mean, I think we could do a whole 30 minutes just about pappers and helmets and different options there as well. So I think that the goal here is to drive questions and then to let our company know how we can help. I know we saw some questions here about fit kits and distribution and trying to help companies out. That's what we're here for. We actually manufacture these products. Laser Vision is the manufacturer of these products. We design, spec. We are a global company, so we will help you with what is the best fit, what is the best lens, what are the specifications needed for your laser. I know I had a comment in here too about using the wall and which walls are good. So we won't get into too much detail, but just let you know that we can help you and we can help guide and build enclosures and safe working areas. And if we don't know the answer, then we will find out the answer. Because to be honest with everybody, this industry is just, it's happening in front of us. We're all learning. We're doing studies. We're doing all sorts of stuff. So it's really an exciting time. And I just, I'm really appreciative to be a part of all this. It's just very interesting.
So there are several questions, Andy, that came in about training, where we can get training and become an LSO and so forth. You guys want to address that?
Absolutely. So first off, we will share with everybody how to get in touch with Rex for his training. Again, Rex is going to do application training. He's going to do high-end corporate, all sorts of things on how training or how laser welding can be used at the maximum effort, and group training, on-site training, all of that. Rex is going to be able to help with all that. Where laser vision is going to come into play is it's more about the safety. So it's what is an LSO? How do you become an LSO? So that's where we want to make sure people understand is that if you want to learn how to use your laser to the best it can be, and how to source the laser and all those questions, then Rex is going to be a really good asset. And he's got an organization for that. And in regards to safety, then we're going to be your best asset. We have online courses, and we can help determine what's the best course for you. And we have people on staff that can really take those questions. I think we have just one more question that we can take here. Somebody commented about interlocks. So this is a good question. Again, if people aren't familiar with lasers and enclosures, Laser Vision offers enclosures and curtains with an interlock system. But can you just explain what that means?
Yeah, and this is even probably a much deeper conversation in terms of what types of engineering controls are available on different types of machines from various manufacturers at different price points. Not all machines are created equal in terms of safety. Ideally, from a minimum safety requirement, you want your systems to have a nozzle interlock, so the laser is only firing when you're touching the part, but you also want the system to have an external interlock. I'd say many of the high-end machines do. Very few of the low-end machines have an external safety interlock. And so, yes, absolutely, I highly recommend that you buy a system with an external interlock, and that you also hook the system up to a safety interlock on the door of your enclosure. This will ensure that the laser will only fire when that door is shut, and will help protect people, those innocent bystanders we mentioned earlier, from accidentally just walking into the cell. So let's say someone is welding and they do open the door, the laser emission will terminate immediately, and it will be a safe, controlled area where whoever opened the door may not have their eyewear on, but they're no longer in danger of accidentally catching a reflection.
It's kind of like and this is one thing that all laser industries have a problem with. When you're going to a newsroom and they have the sign on the door that says on air, everybody knows that there's somebody on air in the back there. And when the sign's off, they know that nobody's on air. It's the same idea here with lasers. If you are in the room using a laser, the sign should be up on the outside of the door saying laser in use, don't walk in. Now, of course, an interlock, if somebody does actually walk in, we'll cut it off. But if you're not using the laser, that sign should come down, right? Because then if the sign's always up, they just assume it's never being used or it's always being used. So one thing, a great practice for everybody is that sign should be up in front of the door when the laser is in use. When the laser is not in use, take that thing down, make sure people are aware of that.
Yeah, and I'd go one step further and I'd say, again, not every machine is created equal in terms of laser safety. Some of the higher end machines as well do also have some outputs on the machine that will actually enable you to turn on a laser emission light externally when the laser is firing. And so you could have an and-on light outside of the cell that turns red when the system is firing.
All right. This is all the information. This was fantastic. I think that this was a great first interaction, Rex. Thank you for this webinar. So much information, right? So Rex, how do people get in touch with you? Just specifically, I don't want people emailing you asking, hey, do I use the green or gray, right? So let's make sure that we understand what Rex does. So Rex, again, for anybody that wasn't here at the very beginning, what does the Laser Institute do? Just so everybody knows why they would contact you.
Yeah. So, and I know we have a lot of unanswered questions, and I'll tell you, you can ask me. We'll give you some contact information at the end of this. So, my focus with the Handheld Laser Institute is really just to make handheld laser welding a normal thing. So, we focus primarily on research and development, fundamental process investigations into handheld laser welding, hardware, materials, properties, operator training, engineer training, anything that you guys need to know to successfully deploy handheld laser welding or build a program from the ground up. And this is all based on our experience that we gained at SpaceX, building SpaceX's program for Starship. So if you need to get a hold of us, you can reach us through our website. It's handheldlaserinstitute.com. There is a contact form on the website, or you can reach out to me directly via email. You can email info@handheldlaserinstitute.com, and we can get you trained. We can answer your questions. We can help you develop processes, anything you guys need. And of course, if you guys need laser safety officer training, we'll refer you back to Andy and his guys at Laser Vision.
Perfect. And again, the laser vision application, it's the products, it's the training. It's really answering the questions. Again, do I need green? Do I need gray? Let's evaluate the laser. We'll work with you, both large corporations and the individual user in his garage. That's what our company does. And yeah, we're here to support. So again, Rex, thank you. This was fantastic. A lot of fun. Thank you, everybody, for watching. This is Webinar Wednesday. Keep posted. We'll be doing this all the time. Maybe we'll have Rex back again talking about pappers, talking about helmets, talking about application. It's really endless, and that's the fun part. This is just such an extremely fun and great time to be in the world of lasers. So thank you, Rex. Appreciate your time today.
Absolutely. My pleasure. Thanks, Andy.
Thanks, guys.